In this video, we want to look at geometric sequences. Now, we've already looked at some other types of sequences. One type of sequence was an arithmetic sequence, and an arithmetic sequence is where you added the same number each time. So in this case, you would add 3 to get the next term. So what we want to look at today is a geometric sequence, and here is our definition of a geometric sequence. A geometric sequence is the sequence where the ratio of any two consecutive terms is constant. So what that means is you multiply by the same thing to get the next term. If our arithmetic sequence that we looked at before dealt with adding to get the next term, you would add the same number each time. An arithmetic sequence, in a geometric sequence, you multiply by the same thing. Now, for a geometric sequence, instead of having our d or difference, it's going to be our r, or our ratio. And the ratio is what you multiply by to get the next term. Now, sometimes this is easy. And you can see here, 1 times 4 is 4, times 4 is 16, times 4 is 64, and that gives me 4. Now, one way you can do this, though, if you aren't sure what the answer is, or you're trying to do this by looking at a calculator, is what you could do is look at your terms, and you can take 64 divided by 16. 16 divided by 4. 4 divided by 1. And if you get the same thing each time, then that is a geometric sequence. So with a geometric sequence, your ratio, you get that division. If you remember arithmetic, what you would look at is we would take 13 minus 10 to find your difference. 10 minus 7 to get your difference. 7 minus 4. So with an arithmetic sequence, to find the difference, you subtract, and then you would add to get your next term. So for a geometric sequence, we're going to divide. So if I look at the next one, I can take -3 divided by 9. 9 divided by -27. -27 divided by 81. And you see I get the same thing, and if I convert that to a fraction, I get -1/3. And I am okay if you write it as a fraction, or if you write it as the decimal. Now, sometimes they're a little bit harder to understand or to see. So the next one, 8, 12, 18, 27. Now, this is a geometric, but let's say you didn't know. Let's say you want to try to figure it out. So I could first check and see if it's arithmetic by subtracting. 9, 6. So I do not get the same thing. So it's not arithmetic. So let's try division. 27 divided by 18. 18 divided by 12. 12 divided by 8. And you can see I get the exact same thing. So my R is 1.5. Okay, for geometric. Now, let's say we're given some sequences and we want to determine, are they arithmetic or geometric or neither? They're not either one of those. So what we want to do first is try to figure out, how do you get the next term? How do I get from 3 to 6? How do I get from 6 to 12? How do I get from 12 to 24? And kind of think about what's the next term. And the next term here would be 48. So you can see what I'm doing is multiplying by 2. That is geometric. So the next one, 2, 5, 10, 17. Well, I can easily see here that I add 3 add 5, add 7. So it's definitely not arithmetic because I'm not adding the same thing. Let's see if it's some geometric thing. So 17 divided by 10 is 1.7. 10 divided by 5 is 2. So those aren't the same. So this is neither. It's not geometric. It's not arithmetic. If you look at the next one, 7, 1, negative 5, negative 11. And if I figure out here, I subtract 6, add negative 6, however you want to think about it, and that is going to be arithmetic. So we want to be able to determine what type it is by what do you have to do to get the next term. If you multiply by the same number to get the next term, it's geometric. If you add or subtract the same number to get the next term, it's arithmetic. And if neither one of those works and it's some other pattern, then it's neither. Now, if you remember when we had arithmetic, we had a formula. If let's say we wanted to find, here's the first, second, third, fourth. Let's say we want to find the 20th term. We had a formula that was a sub 1 plus n minus 1 times d to find the nth term. That's what we looked at last time. Next, we want to look at what that formula is for geometric. And here is our formula for geometric. It's a sub 1, so our first term, remember, a sub 1 is the first term, r raised to the n minus 1. Okay, this r is what we're multiplying by. Now, notice, by order of operations, right? When you do order of operations, the thing people mess up the most here is you have to do the exponent before you multiply. So you cannot just take a1 times r and raise it to an exponent, okay? So let's look at an example. Find the 20th term. Well, first we need to find our first term, which is just 1. And we need to find our r. How do we find what we multiply by to get our next term? And in this case, we've already looked at this example. It's 4. So it's a of the 20 is going to be 1 times 4 to the 20 minus 1. So now we go to the calculator, and we're going to type that in just like we saw, 1 parenthesis 4 20 minus 1, and we're going to get an absolute huge number, and that's what we get with 2.748. And if you don't know, if you see the calculator, you see this little E11 at the end. So what that E11 means is this is 2.748 times scientific notation 10 to the 11th. A really, really big number. Let's try another one. 3, negative 6, 12, negative 24. If you figure out here, we are multiplying by negative 2. So my 15th term is my first term, which is 3 times negative 2 to the 15 minus 1. And once again, we're going to type that in directly into the calculator to the negative 2, 15 minus 1. And we get 49152. So make sure when you type these in, you don't end up trying to do like negative 6 to the 14th. You'll get completely different numbers. Type it in like this so the order of operations are right. All right, you are now ready to do the homework on section 8.3. When you're done, take a picture and upload it to Google Classroom.